Great, thank you for joining us. Today our panel will explore the future of GIS data curation in libraries, and the speakers will address the traditional ways libraries have incorporated GIS services and how researchers are using GIS. So we're going to start off, and Michael Elliott, an assistant professor at biostatistics at SLU, will talk about his research using GIS. Following that, we'll have Karen Hogan-Boom, a numeric and spatial data librarian at UIUC, speaking about GIS in libraries. I will then talk about my role in data curation in libraries and some of the tools that are available to facilitate that process, followed by Jennifer, who is speaking about some of the challenges and issues surrounding curating data in GIS, and Chris Freeland will be putting it all together for us, talking about using some of the content management systems to manage data. So without further ado, I'm going to turn it over to Michael, who's going to speak about his research process and incorporating GIS into it.
Who recognizes this? So I put this up here just to sort of show that public health has a long history with geospatial data. This was one of the earliest studies before we had electronic geospatial data using GIS. So more recently, we've sort of upgraded. We now use computers, and I have a series of maps that have been used very successfully by public health entities showing some of the problems that we're having in this country with the obesity epidemic. So we'll go through these quickly. You can see basically this is to show that in public health we use GIS as a way to effectively display information and get our point across. And you can see those sort of showed how our country is wrestling with obesity. So how do I use GIS in my own research? Basically I use GIS to look at what we call the built environment, so neighborhood factors like sidewalks, grocery stores, parks, and see how that relates to obesity and chronic disease. So I usually start with something like the chronic disease. Here we see St. Louis and the diabetes mortality rate. You can see that it's not an equal spread across the city and county. There are certainly some areas that are worse off. Now, as a disclaimer, because you all work with GIS, this is not; these dots are not actual locations of people that died of diabetes. This is a dot density map. So if you're not careful with how you interpret it, you could get some wrong interpretations. This data was actually at the census tract level. So, all right, then you can look at poverty status, see if that is what maybe explains some of the diabetes. We'll just go through these quickly. You look at where the parks are to see if people can be physically active. You look at where fast food chains are. You look at convenience stores, both sources of less than healthy food. Grocery stores, which could be healthier. A lot of people in public health, I'm sure you've heard the term food deserts. it's one of the things we like to look at. Recently, it's been somewhat debunked. It seems that even when you build grocery stores in areas that don't have access to healthy foods, the people that live in the area sometimes don't actually avail themselves of the new healthier foods, and people coming from outside instead. And when you put it all together, you get a big old mess. So this is where I usually throw my hands up and figure out some way to get from the GIS data into a stats program or an Excel spreadsheet. You have to come up with some way to aggregate where people are, the number of grocery stores, and then dump it into something else to do the analysis. The dream is to be able to leave it in GIS and do the analysis here, but I would need more time to develop the skill sets to do that. And why don't I have the time? Because I spend so much time finding, and how does this all relate to the presentation? Because I spend most of my time finding data. You have to go through, find your sources of data, then you have to modify the data to get it in a format that you can use. It's a lot easier now than it was when I started 10 years ago, and things were misprojected and it took a lot of time to get them to the right projection. Usually that's a lot easier now. But then you have to limit your shape files. Those fast food, that shape file that you saw there, that was based on Business Analyst, but unfortunately Business Analyst, they have all of the industry codes, but they don't have an industry code that specifically relates to fast food restaurants. They have a restaurant code, so you have to go through all of those records, do searches for like McDonald's, Burger King, other popular fast food restaurants to create that shape file. So it takes quite a bit of time. And then because there are so many different files that we're dealing with, I take a lot of time re-finding the data. So where are some places where I find my data? So I go to the Census Bureau, the Tiger Line files, Missouri Spatial Data Information Service, various city, county departments of planning, which takes a lot of time to contact them and get the data because it's usually not available readily online, the CDC, and then some various pay sources. So here comes the problem. Once I get this data, where do I store all the data? Here you can see a screenshot of just my external drive on my computer. I also, of course, have the hard drive on the computer and various thumb drives that have various files on them and various CDs. And then when you look inside the drive, what a mess, because as you all know, each of the shape files has multiple files that comes with it. And when I'm rushing through an analysis, sometimes I'm very bad about labeling certainly the files that GIS will produce for me. So when I go through and limit one of my files based on perhaps another shape file, have it save it out, I'll go with the default name, which tells me nothing in a week when I'm trying to remember where I stored that file. So you end up with a lot of files that it's somewhat difficult to figure out what you've done. So, what are some of the problems that I face that hopefully we can solve, as you'll hear later on? One, trying to locate where I stored files for different projects. Two, trying to remember what I named the files, like we just talked about. When I'm using ArcMap's default names, it doesn't tell me downstream what those files are. Trying to remember how I changed the files when I've modified them with the absence of notes about how I changed them. I usually end up recreating and redoing my work. Concerns about the quality of the files. So I'm getting publicly available files. I don't know what kind of quality they are. I know those Tiger Line files sometimes don't actually put streets where they should be. Lack of access, and this is the big one, to colleagues' files across the department, college, and university. So within the School of Public Health, there are probably 3 of us that use GIS at SLU, but each of us is going out by ourselves, finding all these files, storing them on our own little hard drives, and basically each of us is reinventing the wheel instead of finding a good way to share our work with others. And that problem is compounded as you look across the whole university, and then perhaps also across the city. One of the things that you immediately run into, though, as you start trying to share your files with others, is a lack of normalization of projections. We're all storing files differently. We also are lacking the metadata, so it's not as easy to tell how we're storing our files. And another problem I run into is if I try to change where I've stored my files or I switch computers, I disrupt my linkages. So now I can't just go into ArcGIS, immediately pull down my files. I have to reset up where those folders are. And one of the things I've tried to do is use a program. Everyone's familiar with Dropbox. So I've tried to use Dropbox as a way to sort of share files with colleagues, but you run into the same problem because their Dropbox shared folder will be mapped under their name, whereas my Dropbox shared folder will be mapped under mine, so I have to remap through ArcGIS to find those files. So it's not a very usable solution. So that slew some possibilities for the future, and we'll hear more in a second here. They've developed the St. Louis Regional Data Exchange, which we just tested out last week with some varying success. But that holds some promise for the future. And then also the GIS portal. The problem with both of these, though, is they're through individual centers. So unless you know someone in that center and have somehow found out about this, you're not going to know that you have access to this spatial data. So I think my colleagues here are going to present some perhaps better ways to store GIS data. So I'll take questions at the end.
My name is Karen Hogenboom, and I work with spatial data at the University of Illinois, Urbana-Champaign. I'm going to talk about academic libraries. For one thing, we all are academic librarians. And I also thought, well, what can I say about other kinds of libraries? And I was, well, nothing. So I don't think there are too many public libraries that have GIS services. They just don't work with that kind of researcher as much as academic libraries do. But that also raises the question, if you're not affiliated with the university, how do you get access to these services? It can sound great, but how do you use them? And I'll touch on that as well. They can be difficult to identify. I mean, I can talk a lot about my institution, which of course you guys are 3.5 hours away from, and you're probably not going to be using us. But I'll talk a little bit about some options about where services might be located. It varies quite a lot where you can get help. For example, if you're at University of Virginia, they have what's called the Scholars Lab, and they have maybe 4 GIS specialists there to work with you. They've got workshops in that single space. You just walk in and you're all set. But from the title of the service, you can't really tell that that's what it is. Often GIS services are located in a map library, which makes a lot of sense. People will work with you there. At Michigan, they have a service called Numeric and Spatial Data Services. You can tell I kind of cribbed my title from them. And at UIUC, we have what's called the Scholarly Commons. And all the kind of computing-intensive research help in the library is located there, including GIS. So you have to be a little bit creative in how you look for these things, either in person or virtually. Okay, so one of the main things we do is we consult with users. And as Mike was talking about, finding data is a huge issue. What do people need? How do they need it sliced and diced? This week I was looking for mortgage foreclosures by zip code. Okay, sure you can find foreclosure rates, but that geographic breakdown and over time as well, the last 7 or 8 years, where is that located and how do you get it in a format that you can just load into GIS? 1 meter resolution, red, green, blue imagery for the state of Illinois. You guys might have found that. It took me a while, but I did find it. So just a whole wide variety of things people are looking for. Latitudes and longitudes of villages in India. So little points for each of those. And again, international data is an issue. If you're working for local government, you probably don't need it, but other people do. Also, we need to help people to choose and use software. ArcGIS is not always the best option. If you're working on your senior thesis and you need a map that shows industrial facilities for a county, you can do that in some other online tools, download the image, and be good to go, rather than that huge learning curve that is ArcGIS. So we talk about that quite a bit. And also, other speakers will go into this in a lot more detail, but we help people with data management and curation. As you're in the heat of a project, as Mike said, you're not always thinking about your metadata. You're not always thinking about, can I share this data with somebody else and have them be able to make sense of it? It's just not at the top of your mind. You're interested in getting your own results. But what we can do is sit down with people and talk about, okay, how is this organized? How is it stored? How is it structured? And just get all that documented for them. It's becoming more and more important. The National Science Foundation and other agencies and nonprofits now are requiring that when you apply for a grant, you have a 2-page statement of how you're going to manage your data and how you're going to make it accessible. People are a little bit panicked. They have not done anything like this before, and they're coming to the library for help, writing these things up and even figuring out what to say. You know, where am I going to store my data when I'm done? You mean I can't just keep it on my hard drive? Yeah. So what are the options for that? Where are some archives where you could possibly put that? How do you semi-painlessly collect the metadata about it and keep track of how you've changed the files as you've used them? So we're able to help with that as well. And again, all that is documented in your metadata. I'm assuming everyone's familiar with what metadata is, right? ArcGIS will generate some of it for you. Okay. And data curation is a little kind of a subtopic of this whole data management issue, and that is, how do you make your data accessible for the long term? Okay, so what format can you put it in so that it can be migrated to ArcGIS 20 when that comes along, or used in maybe MapInfo or in some future open source online mapping program. So we help with that as well. And really, when consultations are concerned, anybody who comes in with a problem or a question or an issue that they're trying to address, we will try to help them. So that's et cetera. Yeah. If you come in, we get all kinds of ranges of things. These are just major trends. Okay, another thing we do is provide access to data. And there's a couple ways to do that. And for this one, I have definitely stretched beyond what we do at Illinois. Okay, we just don't have the capability to do everything we'd like to. We do have a site that compiles some good sources of data. As librarians do this all the time. They decide what's worth collecting and what's not. So we've done this with geospatial sources. And here's that site. Can't read it too well. Kind of suspected that. But if you see what's circled, we've got links to sources on our main page here. And then here's the geospatial data sources, the top of the page where we have those linked. And it's quite a long page, arranged geographically, the world, the U.S., and then some local Illinois and Champaign-Urbana things. But you see these all over on academic library websites. You'll notice many of these sites are freely available. So anybody can come in here, say, okay, what's a good source for historical imagery? Oh, the Historical GIS Clearinghouse and Forum from the Association of American Geographers. Okay, I can at least look there and see what I can find. So those sorts of things are going to be available to you off of academic library websites totally freely. And normally, I don't think in this screenshot there aren't any of these, but a couple of these are subscription sources that we pay for, and they're marked. This is a UIUC subscription. You're going to have to log in order to use it. But there's plenty else there as well. Okay, and the next thing, geoportals. This is kind of what I wish we could do. Okay, there is an open source product called Open GeoPortal, and you can put it up. You get a map interface. probably can't see too much of that either. But what I've done, I've searched by subject for railroad, that's the circle up on the left, and gotten, just pages and pages of shape files of data about railroads, which I can then map over to the right. Most of them are freely available. You see there's 3 rows of icons there. The first one is the institution that owns the data or is providing access to it. And this particular instance of OpenGeo Portal is Tufts, MIT, and Harvard. So it's their data or things that they've loaded on a server and provided access to. In that kind of lower circle, there's 2 little, on the right, 2 things that say login. So those are data sets that that particular university has purchased. You're going to have to be affiliated with them and log in to use them. But the other 30 on the page, you have complete free and open access to. And the reason I like to point this out is that it's a great search and discovery tool for data. And you can get there just off the open web. So you can explore the metadata. It's the FGDC metadata. And I believe, we're hoping to institute this at UIUC, and they're about to roll out a tool that'll generate your metadata partly automatically and partly just as kind of fill in the blank. So it's making that process a little easier too. Okay, you can also do a geographical search. I searched for Missouri. It's like all these schools are in Boston. What do they have about Missouri? A lot. Okay, this is one of maybe, I think it was about 5 pages of Missouri data. And I zoomed in on St. Louis, and I displayed, I'm like, what are census key geographic locations? I couldn't figure out what that would mean. They're all shopping centers, for whatever reason. So, I pulled up the attributes of the one right beside that box. It's the Galleria. So you can display that, see what it is. You can change the background up on the right to be a satellite image if you want to do that. You can change transparency, borders. So, all kinds of display possibilities here, as well as finding. The circle over on the right is where you would do the transparency, borders, searching opacity. So you also have a lot of options for saving and printing. You can download the data if you want to use it in ArcGIS or another tool. You can download this image, which sometimes all you need is just a shot of whatever you're displaying, and that makes it easier. And again, you'll notice, especially this far away from where they are located, everything here is freely accessible to download. Okay. The other thing we do is we do subscribe to data, and there are some major tools. I'm just listed what our major subscriptions. Are people familiar with these? Mostly. SimplyMap. A lot of business data in SimplyMap, as well as the most recent couple of censuses. So in very nice geographic breakdowns, good cartography options in it. But again, you can download, you can display and download an image. You can, I think it's SimplyMap, you can create little movies. That might be Social Explorer, actually. So all kinds of, and interestingly enough, those top 3 are all very census heavy. We have a lot of census data users. We also buy small data sets. These are a couple subscriptions. CountryData.com is political risk data for different countries, like for instance, stability of government, conflicts, hunger, just things that relate to political stability. And the UN does industrial statistics by industry, very finely cut, production data. So those are things people have asked for. We also buy individual data sets for people. As long as we can make them accessible to our entire campus, we will try to go ahead and purchase those. Things like there's an association that's actually headquartered in Missouri that publishes fertilizer data. how much of different kinds of fertilizer are applied by county nationally. We had somebody who needed that. Okay, and another thing that we do, and this, the keynote this morning was a great lead into this, is that we work on getting people more literate about data. Again, being able to access, assess, manipulate, summarize, and present in an effective way. Okay, not just, oh, I've got all this data, I can make a map, but what am I trying to say with this map? And how can I say it best with the data I have? And we do that in several ways. I was amazed that, the big tutorial at McMaster that he demonstrated cost, he said, $80,000 to $100,000 to produce. Big online geodata literacy tutorial. It's like, okay, that's why we don't have one of those. But we do teach workshops. I do a GIS 101. We never even open ArcGIS or GIS software. We talk about layers. We talk about vectors and rasters. We talk about, 10 layers about a city, but if you're trying to cite a pizza restaurant, do you really need the elevation? You need the roads, you need where your customers are, you might need the zoning. You have the elevation if you want it, but it just creates a mess on your map, all that extra data. So those kinds of concepts. We offer sessions with classes and groups, so you'll go in and talk to a group of people. We don't have a lot of uptake on that, and I think for a couple of reasons. We did a survey of instructors at UIUC about how they work with data with their classes and how they what their struggles are. And they do say, my students just aren't that data literate. They use different words to say that, but that's what they're saying. But they're also saying, I do not have time to have a librarian come into my class and teach this. And it's not, as the keynote speaker was saying, it's not really a one-shot, come in for an hour and you leave and they're all set. So how do you do that? And that huge tutorial at McMaster is one way. Another way is just these online guides that people have created. There's a whole database of them at libguides.com that, again, are openly accessible. And I'm just going to show you those. This is just their main page. And you can search for the topic that you're interested in. I just entered GIS and got a long list from across the country of different sites that libraries had posted about GIS. And some of them are the same kind of sites that I have, just lists of resources in different areas. Others are very data literacy focused. So, and here's one of those. The contents over to the left, they've linked to some Esri tutorials, other online tutorials, some books about GIS, various databases, probably the Simply Map, American Fact Finder, Tiger Files kind of databases, some journals, an RSS feed about ArcGIS 10.1 new features. So all kinds of things, how to keep current about GIS, organizations where you can get more involved. So this one's really focused on getting yourself into the GIS community, keeping yourself informed. Okay, so how do you kind of get into some of these services? How do you access them? There are just some factors to think about. One is, is the university you're kind of targeting, the one that's in your town, is it public or private? Because just by the nature of it, private ones are sometimes a little harder to just walk in and get help. I'm looking at my Washington University colleagues. Is that true?
I think we're open.
Pretty open?
Yes.
Okay. So it varies. I know, like Northwestern is not so much in Chicago, University of Chicago, not so much. But I would look for a couple of things. I would see if you can get access to a land-grant university, because part of their mission is to serve their state. You can go in. I know we're a land-grant university. You can get a library card if you're a resident of Illinois and check out books and have access to any services. Even if you don't want to check out books, you don't need a library card. You can just walk in and ask questions. So that can be true there. The other thing to look for would be a federal depository library. And that's a library where the U.S. government sends information, and at this point it's kind of sends in quotation marks. They send you links to put in your online catalog. And with the understanding that those resources are for the citizens of the state in really your congressional district, because there's at least one in every congressional district. So if you look for those, you're pretty sure to be able to get in. Even like at Washington University, if you can figure out who to talk to or call and ask who to talk to, sounds like they will help you. So that's definitely an option. And as I've demonstrated, library websites are available to anybody, and there's often contact information there. Sometimes there's a chat reference box, an Ask a Librarian, where you can type in your question and a live person will respond back to you. I don't know, it's kind of hit or miss whether somebody who knows something about GIS is actually on there, but you could at least say, who do I talk to about this, and get an email address, phone number for somebody. Okay, and the old-fashioned way, you could call. Just call a main reference desk and figure out who you need to talk to and probably be forwarded or get an email and be able to access those services. Okay, and that's what I had. And again, I think we're taking questions at the end, so thank you.
My name is Cynthia Hudson, and I am the Digital Data Outreach Librarian at Washington University in St. Louis. And today, my talk is going to be less GIS focused and more focused on the tools that exist to help you curate your data. So when I say digital curation, I mean applying strategies and processes to ensure that your data is available and accessible and preserved for the long term. And there's a lot of free tools out there to help you do that. So without further ado, has anyone seen this model? Some people familiar with it? Yeah, I know you have. It's a little hard to look at, I realize, but what we want to focus on is this red outer rim. And it's actually one of the most well-known conceptual curation models. It was created by an organization out of the UK called the Digital Curation Center. And it essentially steps you through the process of conceptually what you need to think of when you're trying to keep your data around for the long term. So if we start at the beginning, off the chart in this case, is the conceptualization phase. So this should start before you even begin collecting data. You want to take the time to sit down and think through how are you going to collect your data. Is the data or the methods I'm applying going to answer the questions I have? Things of that nature. How am I going to store my data? What metadata am I going to apply? How am I going to organize my files? Best practices for that sort of stuff. At Washington University, one new service we're actually providing that Karen touched on was helping develop systems infrastructure. So a faculty member comes to us and they're planning a project that involves data in some way, and they're like, well, how do I store the data? What do I do with it? And we're available to come in and consult with them about how they could possibly do that and using what technology. Do you want it on a SQL server? Do you want to use one of these open source or more open source sorts of technologies or what? So a fantastic tool that was developed out of the California Digital Libraries is called the DMP tool. Karen mentioned it as well, or mentioned the fact that many funders are requiring data management plans. And this tool essentially will step you through the process of writing a data management plan. And you can export it into a text file and just include it with your grant application. Or if you just want to create one so that you conceptually have an idea of how you're going to organize your data. So it can be really useful in that regard. And it is free and open to the public. You don't have to be affiliated with the university. There is an option for that. but you don't have to be. So after you conceptualize, or you have like this framework for imagining your data and how you're going to do it, you then want to create it, or if you're using somebody else's data, you want to receive it. And as part of the process of receiving and creative data, you should be adding metadata even at this stage. Metadata is, I think somebody said the other day, it's like housework. You know, it takes a lot of effort, but it's you want to clean house, because otherwise you just get a mess, and that's no good. So one awesome organization that does this really well is the Purdue University Research Repository. This is actually built on a software application called HubZero, which is an open source product. But it's essentially a two-part sort of instance. They have a place where faculty can work on projects collaboratively. So you can have various members, even from outside the organization, come together. They can upload files. They can chat. There's like social features as well. So it's really cool. But then they also have this other facet that's the repository. So people can upload their data directly into Purdue's repository. And like I said, this is built on something that's totally free and that anybody can work with. And I see like organizations and communities sort of going in this direction. It's the equivalent of a very easy virtual organization in many ways. People coming together with similar interests in one spot on the web. So it's very cool stuff. And you can work on metadata and create those sorts of things in there. So after we create or receive, we want to appraise and select. As cheap as storage space is, you don't want to keep everything. It's like we all have hundreds, if not thousands, obviously, of digital photos, but they might all not be good. And so it's really important to you don't want to keep all the bad ones as well as all the good ones. So it's really important to go through the files you have to make sure that you're keeping the ones that are going to be the best for the research you're trying to do. And there's different ways to do this. If you want to, you can just think in your mind, well, if I publish something or I put something out there and somebody comes back and asks me questions about it, what is the minimum amount of data I'm going to need to provide them so that they can understand that. There's lots of different ways to look at this as well. Jove is essentially a framework that was created by JSTOR and the Harvard University Library, and it provides functions to perform format-specific identification, validation, and characterization. So if you are receiving files from an institution or an organization and you don't know what's there, you can use the Jove framework to ask this group of files what they are, and are they really what they say they are. And understanding what you have is sort of the first step in, doing something with it and preserving it. So it's a good tool that can kind of get you there. After we assess and have an idea, we then want to ingest or take it into a repository. And ingest is simply transferring the data to a curated environment or repository or something like that. And one tool that facilitates the transfer of ingest is SWORD, which stands for Simple Web Service Offering Repository Service. And it's just a standard that allows digital repositories to accept content from multiple sources and multiple formats. So it's something that the industry is set up to make things easier to share files and do those sorts of things. And it's easiest to think of it about in relation to like HTTP protocol. So in the way that HTTP allows any web browser to talk to like a web server. That's what SWORD does. Another tool that facilitates ingest is the Duke Data Extensioner. Excuse me. And it's a plugin that facilitates the migration of data off of disks and onto a server space. So if somebody comes to you with CDs or something, it can look at those, and it actually creates metadata automatically as it's bringing those things in. So once we have ingested our data, we can start applying many of our preservation actions. And these are the super useful things you want to do to check that bit rot doesn't happen, to make sure your files don't become corrupted, all those different things. And one of the easiest things to do that's also free is to create checksums. Checksums are essentially a unique hashtag that is attached to whatever, typically like a digital object. It can be like a GIS data set or something of that nature. And as I said, these work to detect data corruption, bit rot, and file integrity verification. So if you move one file to another, you want to make sure that it successfully arrives. You can attach a checksum to it. And there's lots of different checksums. This one is an SHA2, there's MD5s, I think there's even SHA3s at this point or something. So it's a good way to ensure your data, if you move it or if you do something to it, it's the same as when you started. Or if you notice that something did change, that the file was changed in some manner. So the next tool, this was developed by the National Library of New Zealand. It's a metadata extraction tool, and it works with a variety of file formats to actually extract preservation level metadata and output the metadata in XML format. So you can have images, PDFs, whatever, and it'll go in and pull out some preservation metadata for you and export that in an XML format so you can attach that to your metadata files. So once we have added all our preservation mechanisms, we want to store the data. One of the largest storage softwares available for free is that of Fedora. Are you guys familiar with Fedora? Anyone heard of it? Okay. I think Chris is going to talk about it some more. But essentially, it's really fantastic because it incorporates automatically a lot of those preservation mechanisms we talked about earlier. So it can facilitate that and automate a lot of things for you. So once we have it stored, we want to make sure that the data is available for access, use, and reuse. One specification that facilitates the transfer of digital content is called the Bagot packaging format, and it's just essentially a standard where digital content is packaged along with a small amount of machine-readable text. So that would be it would be your image file plus some text that included your checksum or something like that. And it's just essentially another standard that we can use to ensure that once you transfer your data to a repository or to another entity, that it arrives in the same manner that you sent it. EasyID. This is developed by the California Digital Libraries. It is a wonderful application that allows researchers at that institution to create DOIs. And DOIs are digital object identifiers. Some of you may be familiar with them. They're very ubiquitous in the journal articles, but they're essentially a permanent URL for any object and a permanent digital identifier for any object. They can even be for physical objects, but mostly they're used for digital objects at this time. And like I said, they're pretty well known across the scholarly publishing arena, but I can see them moving more into digital collections. If you can imagine, if you need to cite where you receive the data from, a DOI or a permanent URL for that is going to facilitate metrics and citations a lot easier than a URL that could change over the time, or if the data moves or if the site goes down. DOIs are meant to be permanent. An EasyID option that California Digital Libraries have put together. DOIs are not, are not free. Actually, I don't know if that's true. I think there's different institutions you can go to create them. And then finally, transforming the data. So this is the last step. This can include migrating the data from to a new format, creating a subset, and even adding layers. So one of the most popular ways to transform data, or that you guys might be familiar with, is like Galaxy Zoo. So crowdsourcing. Those people are going in there and they're changing the data in many ways by adding attributes and things of that nature. Map Warper is an open source map warping or georeferencing tool. In this instance, it's been embedded at the World Map site created by Harvard University. And the tool digitally aligns and rectifies and georeferences scanned historical images. So visitors can even upload and georeference their own maps. But it's all based on open source software. So as you may have learned, there are many free tools available to help you through this process. And we can talk more at the end if you have questions about other ones. Otherwise, I'm going to turn this over to Jennifer.
Hi, everyone. Thank you for coming. As Cynthia mentioned, I'm Jennifer Moore, and I'm the GIS and Anthropology Librarian at Washington University. I'll start by saying that when I joined Washington University, I was only the Anthropology Librarian. And in my first meeting with my department chair, I learned that one of their biggest needs was for the library to take their geospatial data. So because I have an interest in data curation and GIS, I began becoming more acquainted with the field, but I will say I'm not an expert. So what my presentation will include is both research I've done, but also I reached out to experts, people who are actually curating geospatial data, and asked them what their greatest challenges were. Cynthia introduced the data curation life cycle to us, and as much as possible, I'm going to try to relate what I talk about to steps in the life cycle. Probably you'll just notice them by the arrow on the slide more than me remembering to tell you that this is when this might happen. But I do hope that there's some connection between the two ideas, and even to everyone that's spoken so far and that will speak. One of the data curators I spoke to was from Cornell. And he said one of the biggest issues they face is encouraging researchers to give their data in the first place. And that's because it is not a painless process. And one of the jobs of the data curator is to make it as painless as possible. This isn't something that is necessarily particular to geospatial data curation, but because it is a complex data formats, it can be a little bit more of an issue. So the first thing we need to think about with it is provenance, which is the origination of the data. And really there are 2 points to consider in that. One is, where did it come from? Where did it start its life? And also, where did the researcher get it? So they could have collected original data points themselves. They could be using licensed data. They could have purchased it outright. It could be public domain. All of these possibilities have their own issues. The most tricky one, I think, is licensed data, because every single license is different, and the data curator has to give attention to that license to know what the researcher is even able to share. As Karen pointed out, researchers are increasingly asked to share their data from their granting organizations. If they're using licensed data, they might be inhibited from doing that. And even if their license allows it, what happens when their license runs out? So there's no one good answer to that. I'm sorry. But hopefully we can have discussion about it. I'm sure there are people in the room with expertise. Oops. In relation to where it originated from, how do we know if it's authoritative? Often when we think about, as data curators, when we think about authoritative, we want the closest to the original collection. But sometimes the data is improved by value-added information that some other entity is added. So is raw data more authoritative, or is value-added data more authoritative? Is it better? Does it matter who the source of the collection is? And probably it does. Quality is an issue that cartographers have faced for centuries. Is this data right? And as a data curator, we definitely want to assist the researcher in putting forth good quality data, because often what we know about researchers, the end user is also the data provider in many cases. Depending on their level of expertise, a lot of time they believe the data that they find, whether or not it's right or not. So as data curators, we have to give attention to whether it is in fact quality data. So that kind of connects to derivatives. All of these things really intersect and overlap. So there's the license issue. What can we do? What kind of derivatives can we make from our original data? Once they've got the value-added elements and they've been changed and manipulated, are they still authoritative, and how do we present them in our repository? That also speaks to accuracy. And the other issue, which is really a moving target for geospatial data, is the currency. Because the data curator wants to keep the most recent data available in the repository. So it's an ongoing relationship with the data provider and the data curator to make that happen. And that can be a lot of legwork, really. And that's tied to versioning, so we need to not only keep the data up to date, but we need to make sure we're aware of the different versions that have been that have existed and have been in the repository. Part of the complication with this is the diverse data structure of GIS data. Oftentimes, as you know, as practitioners, in your research or in your work, you use a lot of different kinds of data formats, sometimes within the same container. And that is a complicated issue for a data curator because it's hard to extract the different layers and make them make sense again without the context. And that we'll talk a little bit about the issue of metadata again, but geospatial data is so diverse. It could be in it's continuous, it's discrete, it's together, it's those two things together, and this becomes an issue, especially if the data curator doesn't have geospatial expertise. And that ties us to data management. So we also, everyone in the room, I'm sure, also realizes that geospatial data is very large. One of the curators I spoke to said that sometimes they have to break the files apart to do anything with them at all. And even sometimes they have to aggregate. And this kind of is an issue when we think about curation, because we are trying to preserve the best quality, best representative of the data that we have. And if we have to break it into these pieces, there are issues there. Also, the formats that are involved, and again, there are many, but for example, when we create geospatial data, there isn't one standardized format that everybody says this is the best. Some formats are becoming obsolete, like coverage files, proprietary files, which are not necessarily supported across the board, like file geodatabases, which offer us such robust possibilities when we work with GIS data, but are not versatile. Shapefiles are more versatile, even though they're also proprietary, but they're more widely supported. So I think data curators really prefer that data comes in the shapefile format, but you can't really ask that of researchers, especially when there's a tool like file geodatabases that is more versatile in their day-to-day work. And another issue is the best practice of data management. And one of the curators I spoke to, Dorothea Salo, said one great issue is researchers' lack of value of data longevity and ad hoc processes when they're working with GIS data. And I think that Michael said it really well, the heat of the moment. You're not thinking about what it's going to be like to find or use this data or let someone else use it. You're trying to accomplish your analyzation process. So it's something that something we sort of have to promote before people start working with GIS data in depth, so that when they are in the heat of the moment, it's a practice. It's not something they have to develop on the spot. Ad hoc processes never tend to work out so well in the long run. The other issue is naming conventions. I'm actually sorting through some metadata that was delivered to us, and there's some files that are called things like tiff.tiff. And, sid.sid. I mean, it's just not there was one actually called metadata.shape. So, I mean, we have to establish these things because, again, with ad hoc processes, we don't necessarily make the best decisions. So, and another issue with data management is when the curator gets the data from the geospatial researcher, all of the fields that are in the data may not be meaningful to everyone. So there are two things we can think about in terms of cleaning up those fields. Number one, can metadata sort it out? Well, if we apply the right amount of metadata so people can understand the context of this, will that solve the problem? Or is it something that just needs to be removed? Keith Jenkins particularly mentioned this. And also there's the issue if they're working with subjects that may be protected, like they have are you familiar with the IRB? It's a human research requirement. So they might want to de-identify people in those fields, or take it out altogether. And then the question is that the job of the data curator, or is that the job of the researcher? The researcher has the subject expertise. The data curator is trying to make this process as easy as possible for the researcher. Does the researcher have time? In the end, it's probably some combination of the two. So the whole process, if you hadn't already thought this yourself, is very time-consuming. You know, it takes a lot of work to get the data in the kind of shape it needs to be in order to be useful to other people and to be preserved in the long term. And one of the main issues, and you've heard about it many times already in this presentation, is metadata. It's really the backbone of the curation process. And data curators say it's a big challenge because researchers often don't document their data along the way. And researchers say they don't want to be bothered learning a metadata standard so that they can share their research. They need it to be a simple form and as easy as possible, and to take as little time as possible. So, in the best case scenario, we provide good tools that make this collaboration between the researcher and the data curator easy. However, we don't necessarily have those tools yet. One of the researchers that I spoke to is Dorothea, and when I say that she's an expert in the field, I mean she's a rock star. She knows her stuff. And so her complaint about the ridiculous complexity of FGDC metadata should not be taken lightly. One issue with geospatial data in general is that a lot of metadata standards try to incorporate a wrapper to bring in the administrative and the technical metadata. Geospatial metadata standards don't seem to have this, as far as I know up to now. The administrative and technical metadata look at things like archival rights and data acquisition and transfer, and this is under development in the geospatial realm, but not quite. There are working groups and standard bodies that do keep looking at these things, but right now we don't have the best answer for metadata. Let me just back up and say, descriptive metadata is what we want from researchers. The wrapper is what would capture the administrative and technical metadata. Yes?
Past metadata. So to me, metadata is two different things. What is the history? You know, where did this come from? The genealogy, if you will. It's also how I'm going to go back and find data again. Where is visual search? We're talking about visual data. There's, to the best of my knowledge, nobody developing any capability for metadata as a visual search. I'm just throwing it out there as a possibly rhetorical question.
Well, let's kind of discuss it as a group when we come to the end. Is that all right?
Fine. That's great.
Thank you. That does bring us nicely into data access, because that's why we need metadata, whether in whatever form that it is. If we expect, we don't want to just archive and preserve this data for posterity and keep it in a cave. We need it to be accessible. And I think Karen and Cynthia both touched on these things well, and I know Chris will say a lot more. And Michael really expressed the reasons we need these things to be findable, and as easily findable as possible. But to just highlight that the data curator's job doesn't end at making the data preserved. It's an ongoing process, because the data provider is the data user and vice versa. So I just wanted to mention a few good examples of data curation. And when I say good examples, I kind of mean that they're intentionally working on making these processes better. And I'm sure you're familiar with GeoMap. It's it started with the North Carolina Spatial Data Archival Project, and it's a multi-state project. And they're very intentionally looking at what we need to do to preserve geospatial data long term. On the question of metadata, they wrote a report saying, what we need is not here. Maybe we need to combine a couple of standards to make it work. So they actually use FGDC and Dublin Core together. Dublin Core is a very kind of broad metadata standard that put together with FGDC kind of makes it a little more discoverable, but the FGDC offers the geospatial expertise. Insight Idaho is a geospatial repository out of the University of Idaho, and it's covering the whole state. But they've just recently published an article on the issues they've faced in geospatial preservation and archiving, and are making some great strides, and is a good starting place if you're interested in looking at the issues behind geospatial data curation. And of course I mentioned QGAR, which was one of our QGAR, which is one of our experts spoke to us from there. And they've been leaders in the field of geospatial data curation and preservation and sharing for, I guess, about 10 years, I'd say. So finally, just from our point of view, we're in a starting place, really. So I just tried to pull together a few things that we're thinking about in terms of what we need to do to get on the path to curating our researchers' geospatial data, because it's being asked of us. And one of the things is the very first starting point is to anticipate these difficulties and find ways to address them. And one of those ways is creating a geospatial data collection policy. And a good example from that is NGDA, which is a collaboration between, I believe it's Stanford and University of California, Berkeley. And they have a model for creating this geospatial data collection policy that clarifies to the people you're serving what it is you can and want to do for them and what their responsibilities are. We also need to foster this culture of best practices. So we have to help researchers make these processes more regular in terms of their naming conventions, their application of metadata, etc. And that has to be an intentional effort from the libraries. And as well as developing relationships with other institutions. I think in all the examples we've heard today, we haven't heard many efforts that were one institution working on its own. And certainly for preservation, other institutions need to be involved in order to keep the copies preserved in the long term. And working on a geoportal for our research that can be either ours in consortium with others, or something we contributed to make our researchers' data also available, are things we're thinking about. So anyway, Chris is going to take us into digital assets management systems and talk a little more about access.
My name is Chris Freeland. I am an associate university librarian at Washington University. This is my third week in the job. Previously I was at the Missouri Botanical Garden for 800 years, 15 actually, and I was the director of the Center for Biodiversity Informatics, and I was responsible for some of our geospatial analysis work and some of our museum management systems. So I describe myself as a recovering biologist who has landed in library land because my background is in biology. I was always interested in technology, and it was GIS. That was when I did a GIS course in college. It was sort of the aha moment. I knew I wasn't interested in field work, so I didn't know what I was going to do with biology. And when I saw GIS, I was like, "Hey, technology, that's the right approach." So I'm going to talk about digital asset management systems and hopefully try to draw some lines through some of these the data challenges and the data curation problems, and how some of these systems do and do not address the challenges. So a digital asset management system, or DAMS. It's a combination of hardware and software that's used to store digital assets. So things like Word files, or documents, or media files, audio files, and including data sets. These systems really came to the forefront in the late 90s, early 2000s, when libraries were getting funding to do digitization projects. So there were lots of media assets, new media assets that hadn't been managed before, and so these digital asset management systems kind of came on the scene in a very strong way, and the libraries started integrating them into their system architecture. So from a very high level, a digital asset management system simplifies some of these issues of where is it and what is it named and what is its metadata that doesn't have to be bundled with the file itself. So imagine, oh, I have a pointer. Imagine someone taking a picture with a cell phone and dropping it into some kind of a system. And these dams provide user interfaces and or APIs, application programming interfaces, for machine-to-machine communication that allow you to add an image. And then it separates this, the dams keeps track of the metadata about that object and its location, and those are two separate things, so that you don't have to worry about what's it named and what information is contained within the file. And if you move something from drive A to drive B, this is what the system does. It keeps track of all of these objects and the information about the objects. And then hopefully systems are also open enough that you can provide API access so that you can build applications on top of them, so that you can extract out your geospatial imagery or your data sets and build a custom application. And I'm going to show an example of that that we did at the Botanical Garden. Lots of different ways of talking about a digital asset management system and ways of clumping or grouping them. You can look at proprietary versus open source, different ways. I went, kind of followed the same theme actually, of going from a personal archive to an institutional or shared repository to enterprise solutions. And this doesn't even include, well, if you think about like an enterprise solution, when I think of an enterprise solution, I'm thinking of something that's media rich, someplace like a publishing company, Condé Nast, that publishing magazines, websites, lots of media, multiple places. They have to have some management system that can bring all those things together, that can manage all their digital assets. Those, you can also think of these as the numbers of zeros after the dollar sign, right? So these are tens of thousands to hundreds of thousands of dollars of solutions. Institutional repositories, I'm going to talk more about Fedora Commons. Another frequently used institutional repository is DSpace. And then I think that these research repositories are the wave of the future. I think this is what we're going to see more of these. And these are more in the free to tens of thousands of dollars to implement, hopefully not in the hundreds of thousands of dollars. And then like personal asset management, Dropbox is a good one. Flickr is another example. Evernote is something that I use for taking screenshots and making notes. And these things are usually free to $10 or so. So zeros up the board. Now, connecting GIS and digital asset management systems. As I was preparing this, I went and did some searches, and I stumbled across this outdated forum that made me laugh a little bit and cry a little bit as well. Because if you can see it, and you may not, this was asked in 2003. The requester was saying, we have a large custom map archive, it's in CONCEPTUALIZE, but I want to be able to connect that with ArcGIS. That question was asked in 2003. There were no replies. The forum was closed. In the new forum, this question has not been asked. So I think the answer is there is not a little to no native support for making these connections between systems, and it requires custom programming. And that was the initiative, the task that I had ahead of me when we were integrating a GIS system, ArcGIS server, into a project at the Botanical Garden. So I'm going to try to bring this all together as a case, an example of a system that integrates both a GIS system and geospatial data and a digital asset management system. The Tropicos is the Missouri Botanical Garden's botanical information system, and it contains information about this act here, which is a biologist goes out in the field, collects a plant, and then it comes into some museum storage, or in this case, a herbarium type collection of plants. So that whole life cycle of what happens from the point when it's extracted out of the ground, who did that, where were they, what does it look like, what were some of the elevation, all of that information is usually written down on paper and then follows it into the, being databased and follows the object into the museum. We also map using Esri tools and other technologies like Google Maps. We had ArcIMS running, started in about 2000, and it was only recently taken offline just a couple of years ago. So it ran for a good long time, producing very basic dot maps. We integrated ArcGIS server. At that time, it was 9.3, which was about 2009, 2010 when we were working on that. And recently, about 6 months ago, upgraded to server 10. And then the digital asset management system that we used was Fedora Commons. So I have some screenshots. This is a look at tropicos.org, which gives you facilities to do searches on different kinds of information, whether you want to search on the collectors or on the specimens, a location-based search. And I'm going to do a name-based search. So in the dialog box, I've pre-typed a scientific name. It's Heuchera sanguinea. Heuchera sanguinea is coral bells, which you may probably all of you have in your shade gardens or your neighbor's shade garden. It's very common. It's a leafy plant with a red crimson flower up on a stalk. Very pretty. Used to be a native plant. Made us move into lots of cultivation, lots of hybridization. But it did start off as a native plant in the 1850s, or first collected. So I did a search for that name, and this is showing then all of the information that Tropicos has. This is all, think of these things as, this is metadata, museum metadata about the object and about that collection event, including digital images. So I'm going to click then on the Specimens tab. Difference between a specimen and a name. When you collect a plant, it doesn't tell you what its identification is. It's just a plant. So specimens are just the objects that are collected. Names are applied to those specimens afterwards. So it's not as though when Pringle made his collection in 1888, it's not as though the plant announced itself as Heuchera sanguinea. Someone came in after the fact and said, this specimen is this plant name. So a connection there. I'm looking at all of the specimens for this name. And I can look at all regions, all countries, and click on and make my selection of the different kinds of mapping interface that I'd like to use. And I'll click on the Esri map, which brings up then this display. So these are the locations at which plants were collected. The color coding is by the different names. So this view is looking at 3 different collectors over all time. This is not a time-based view. This is the aggregate of this is the composite of everything. And so we're displaying at this location, then this plant was collected by Friedrich Wislezinus, who was a Polish botanist, and it was collected in 1846, and a link to the image. So I can click on the little thumbnail to get metadata about the image. I can click on View Full Screen. And then I can use this sort of Google Maps-like interface to zoom in and see greater detail of this little piece right there. So how does this all work? How does it all come together? System architecture time. I won't say the interesting part, but it all comes together. I was able to grab this slice of where GIS and a digital asset management system and custom programming were all coming together in about 600 pixels. So that was cool. If you look at this broken off into the GIS side of the world, Tropicos is built, its data store is SQL Server. I get a little too happy with the with the laser pointer. And we used ArcGIS server to provide the base maps and to put the points on the map using the ArcGIS API for JavaScript. So you can see that there is a sort of a GIS path up through the display layer. Oh, I'm sorry, I should mention. So I've broken this out into different tiers. So file system, data storage, application layer, and presentation layer, or UI, or user interface, or API. So that's the way that the map is produced and the points on the map. The thumbnail is drawn, and the link into the larger image is drawn from the digital asset management side. So the image is stored on the file system. The metadata comes from the data store, which happens in this case to be MySQL. The application, Fedora Commons, knows the metadata, it knows the file system, and it can respond to this request and say, you need this little thumbnail for this image that's stored and managed over here in the GIS side. And what brings it all together then is custom programming that happens up at that presentation layer. So when I, as a user, when I clicked on that map that said, let me see this, let me see this map and all the data points, it was the presentation layer and the application layer, a handoff between those two. It was saying, oh, you want to look at this side, this part of the map, which means I need to draw those dots and bring up these images. So a lot of custom programming that happened here in this UI to application side. And we let the the GIS server do its thing, and we let Fedora do what it does best, which is manage this thing, this digital object is in this place, and it has these attributes. So takeaway or the conclusions is that libraries have invested in these digital asset management systems for media storage and delivery. So it's part of the library way of working that we have these kinds of systems in our bag of tricks. There are opportunities for use with these custom apps, but it requires customization and trade-offs and maybe a negotiation of what features we can and cannot produce. It does work. It is not simple. And I think that because of some of these limitations with individual repositories, I think that the move towards community-supported research data portals is probably going to win out in the long term, in the long run, because there's more. It just makes sense to be able to think about sharing your data with others and to try to avoid some of these individual Dropbox file system-based problems. So I think that what I would hope that we could do from this, as these repositories start getting more widely adopted, we want to make sure that those have some of these features and APIs on top of them that the digital asset management systems do, so that we can ask these repositories to be providing some of that asset management work that we don't want to have happen, that we're struggling with down at the library layer. Okay. And I think now we move to discussion and questions. Yes. So your question was about map-based inquiry, visual search.
Well, I think it's a missing piece. You go to Google image search and you can type in some keywords to get you started, and then you have some thumbnails you scan. Our catalog has a preview. I don't know that it's tied in with metadata search in any way. I'm not a sophisticated art catalog user. But certainly as we try to move tools away from the specialist end of the spectrum, towards the student use or even consumer use, it just seems to be completely missing. Consumers may not need the metadata so much, but I don't know.
So can I ask a question?
Please.
I'm trying to understand exactly what you're talking about. So can I just give you two things that are coming to my mind?
Sure.
So like there are, you have the ability with geoportals to zone in on an area and find, maybe you find what you're looking for that way. Mm-hmm. That's not what you're talking about.
I think if people know, if they have an area in mind, sure, that's, but then you have to decide which version of maybe multiple similar data sets that you have that you want to display to the user. So, for example, what I'm thinking of is my region is limited to Missouri, really, that I'm interested in. And yet the data that I have changes, not on a daily basis, but on a monthly kind of time scale. So if I want to do a historical map or show changes over time, I need to have either a semantic file name with a timestamp in it, or I need to have it in the metadata, or I need to kind of look at it and say, well, this is that's maybe not the best example. But I don't have a way of just looking at a whole collection of objects. I don't have a simple way of looking at a collection of objects and, say, using a visual search as an extra dimension to the keyword search that I'm aware of anyway. I have to do my metadata search, and then I have a list of matches I can't really approach it the other way.
And you can't glance at the data. You can't. You in your in example you gave, you're getting back this result set, and then you're having to make some look at these one by one. Yes, bring it into a system. Do some queries. Yeah, this is what I want. No, it's not.
And maybe it's like you can either do it visually, or you can do it through metadata, but you can't really triangulate. I'm not aware of a tool that allows you to iterate and triangulate between keywords and visual.
David, are you using the portal?
Well, this isn't about MISDIS.
No, I'm not saying that. I'm saying if you're using a portal, you should be able to triangulate those things.
I'm not using a portal for my own stuff, so I'm limited to our catalog.
Because there's a tab there that lets you review the data. There's a tab there that lets you review the metadata all in. I mean, it's on one data set. So if you put in railroad, you're going to get all the railroads available. You should be able to review all of the elements that you were speaking of.
Okay, if you're talking about the geo portal that MISDIS runs, I'm not. That's not what I'm trying to do. Maybe the geo
Our
portal.
challenge is to expose it to the web,
Yeah.
so that you can do a wider search. I think is where you're going.
I think I should look at the MISDIS geo portal more, but I think that would be complete overkill for the data I'm trying to maintain. So I'm looking for geo portal light, perhaps.
Curious, I'd like to talk to you more about this.
The Library of Congress was looking at doing spatial indexing, trying to use keywords, trying to use gazetteers, go through the digital holdings and then start putting geospatial tags on holdings to know this is about France, this is about this city in France, this is about this neighborhood in France, this is this author, and start linking that all together so you could start doing more place-based or gazetteer or name-based searches into the whole Library of Congress holdings and then extract, using the spatial element, everything that's been published in the 1800s on this city in this neighborhood. Kind of an interaction that sort of, they're pursuing that. The visualization of that, though, gets really complicated because in some cases it's a book, with no maps or anything in it, but the information in there is geospatial. So that's where sort of the rub is with some of this, and so it's interesting, the directions that they're having with that and the approaches that they're trying to use, creating that interface. I think what we don't have yet is sort of the data structure that we need yet in terms of that probably better, a data model that actually is sort of a curation data model for geospatial. I don't think that's been created yet. No one's sort of wrapped their head around what that would look like, because I think there's lots of tendrils that come out of that are really going to have to be managed in these digital assets management systems. I think they're set up for a lot more point-to-point than sort of the many-to-many that the geospatial piece has. So I think there's still a lot of, there's going to be a breakthrough. There's going to be one, because it's something that people are wanting, they're asking the question, they're asking more complex questions, and to get the answers to those queries, they want a more complex interface.
And they're, it's also coming from the web and not a desktop app. I mean, I think that's the huge shift that has happened, or not is happening, has happened, and that was actually kind of the same challenge that we were facing at the Botanical Garden. We had all of this, 4 million objects in the database. How do you present those in some meaningful and cohesive way, and knowing that you want to do it in a map-based way, but building that linkage out to the web was much more complicated than if we were just looking at this as a desktop app.
Where do you think and you mentioned it with the individual sort of sectors building out their own data. I mean, there's a whole sort of geophysical database, national research database they're trying to spin up. Lots of different collaborators from all across the country and now the world are starting to put their research and results and stuff into this big monster geophysical database. That's great, but I don't know if the approaches they're using are going to be the same as the ones that the biologists are using, that are going to be the same as and then you have the conflict of vernacular between the disciplines where, you know, this is a ridge. Oh, well, that's your definition of a ridge, but it's not our definition of a ridge. Yeah. So, I mean, you have all of those taking place. How do you think, do you think there's going to be a common organizational framework that's going to come out of best practices or something that's going to start coming out of those to help guide these other ones so they sort of come this way instead of go this way?
I would love to see that, and I think that's the role for like data curators, data librarians, is to help guide that discussion and to, because that's what librarians want to do, help users find information and preserve it and present it in a meaningful way. And when you're talking about these kind of specific silos of data, it's easy enough to say, well, we've put it all together and we know how to use it, but that doesn't mean that these other folks from the outside understand the same way. So definitely there's need for standards and for data exchange and data interoperability advances.
At the University of Missouri, they just started up a Cyber Infrastructure Council. Mm-hmm. And they are trying to meet on this, trying to figure out how to get researchers' data in, get it cataloged, get it, you know, discoverable, accessible, get it archived, etc. And huge issues. Yeah. Huge issues. And there, you know, you're looking at this thing going, this is like eating an elephant. This is like, you know, putting together a dinosaur. And so it's one of those things where, you know, where do you start? So any help that you guys have, the work that you guys are doing, and this would be certainly beneficial to the University of Missouri, as we're trying to figure this out and trying to figure out, okay, what role, we have a role on campus, but that role can't end there because there's this larger research environment, and with the NSF funding and all this stuff moving towards collaborations, interdisciplinary, you're really wanting to bridge these together so that your faculty are successful and the research agendas are successful and are leveraged more appropriately. And so that's the direction they're heading, but they're, you know, struggling.
Yeah, I think that the community-based portals, community-based repositories are going to be more successful than an individual institution, just for some of the challenges that you're raising. We're all in this together. We are all facing these problems. Why aren't we all working on the solution together rather than 5 or 6 different of us in, you know, adjoining states doing our own thing?
Hi, Jennifer. I'm sorry I missed the beginning of your presentation. I was really interested and I got held up outside by the conference crew. As a member of the FGDC and a working group, your comments on metadata really I found interesting.
They were just mine.
I understand, yes. I did see the quote. So I'm curious, 19115, am I to infer from what you said that you guys are not considering going in that direction? I was hoping not.
No, I mean, I put it up there on the slide as well. I forgot to mention it, but like maybe this is a way forward. You know, we're not where we need to be. And I don't think that's for lack of anybody's hard work on it. I think it's because it's complicated.
Just in case you don't know, there was a pushback on the American side, which was the U.S. pushback for FGDC, and let's just say the international community did not respond quite the way we would have hoped. Maybe we were bullies about it. I don't know. But just so you know, the working group is aware that in the attempt to simplify things, we've actually complicated things.
Right.
And the mandatory elements now have become much more difficult to get in there. On the good news side, the 19115 does allow you to create web elements that you can link to, hyperlink to, so that you're not rewriting metadata all the time, saving considerable amount of time for generators. Unfortunately, it's still a complicated data set. And I think this conversation, which I was trying to suggest at the keynote, which is that we need to have a higher level conversation about archiving in the state of Missouri, bring in all the players, certainly includes librarians and universities, but is actually a wider audience than that even. At some point, it would be a good idea to do some planning, some strategic planning, and make sure we get the stakeholders in the same room. Because it's not just about the University of Missouri, it's not just about WashU, Northwest. Everywhere should be involved, and not just academics. So, you know, there's a lot of work to do, and Tim and I have been talking about this for a number of years now, how to do a comprehensive GIS inventory. David's point is well taken, which is we don't expose our data very well. Not even with the portal. Portal was a good step as far as this did is concerned. But
it was the next step that we needed to take.
Right.
But now you're getting into catalogs of services.
Right.
Well, how are those catalogs documented? You know, and how are those? I mean, so there's a whole other, you know, so you know, clearinghouses are playing a role in this, but the clearinghouses themselves probably don't have a foot in this arena. So they're, you know, FDDC, I think, the first to say that they're not, you know, they're not, you know, in the curation idea. They're still trying to get people to document. And I think that's the one thing that the geospatial community has going for us is people have documented it, and if they're willing to document the FGDC metadata standard, you know, you can get them to do anything.
Right.
You know, that's even smaller than that. You know, if there's things that, you know, you don't need this, you just need it. So they have a core, you know, with the Common Core and stuff. You know, so they try to make it a little bit easier, but I still think there's an easier way to document.
there's a lot of work to do. But David's point is, he's an advanced user, and he should never be saying, well, I'm having trouble finding data. Coming from a guy like that, that floors me.
I'm not having trouble finding your data, Mark.
No, and again, this isn't personal or about business.
I'm having trouble cataloging my own data.
Right.
Because again, it's that heat of the moment comment that was made earlier. I've got to make a map, boss wants it yesterday, you know, I'm creating new layers, or I've got to go
I can't
look back
stop
in
the
history.
document because I'm on a roll.
What's the delta?
And you know, when we got the portal, just for an interesting side point, there is the ability there for a user to go in and catalog their own metadata. We create a user account for them.
Mhm.
You can go in and put, we've been testing with Jason.
But that's if I put my data on your portal, right?
No, even if you just advertise your data. No, you don't. You're just putting a metadata record out there.
Yeah.
You're not putting your data on my portal at all.
So I would
My
encourage,
metadata on your
Right.
You guys talk.
carry on the conversation at lunch. Where now it is lunchtime, and so yeah, no, it's great, good to have the discussion, and I want you all to have lunch. So everyone wants to have lunch.
You want to have one.
I sort of do. Thank you all.
Thank you all.